Alrighty, good morning / afternoon to everybody. We're going to go ahead and get started here. This session will be recorded. Welcome to Sterling and VMware's Power Block session. I'm Megan Moore, Sterling's Director of Strategic Programs. And we know your time is valuable, so we want to say thank you for choosing to spend a portion of your day with us. Before we dive into the demo, I wanted to give you a brief overview of Sterling's capabilities. As you can see here, Sterling is a principal VMware partner and a preferred services partner authorized to sell and service VMware solutions to customers across the nation. With 50 plus technical staff and 75 plus sales staff, all trained on VMware offerings, we're sure to provide you with an industry best value on all of your client to cloud IT needs. As you can see from this slide, Sterling holds many VMware competencies, including 2 master services competencies, with more coming soon. Next slide, please. Sterling offers complete customized solutions from client to cloud. We serve on multiple federal, state, and local government contracts and support all industry verticals. Security is very important here at Sterling. We have a very robust secure supply chain, including OTIPs and CMMC certifications. For any questions about Sterling, please use the email aliases you'll find at the end of the demo. For questions during the demo, please put them into your Q&A feature at the bottom of your screen, and we'll make sure to address them at the end. Now I will turn it over to VMware System Engineer Adam Blauner to talk to us about capacity planning with vROps.
Thanks, Megan. Good morning or afternoon, everybody. So we're going to kind of set the stage first with some basic definitions around capacity planning. Talking about overhead, HA, buffer, all these different terms that you see when looking through vROps, just kind of showing how they fit together. And then we're going to go into a few high-level demos on reclaiming and optimizing your capacity resources, looking at a what-if analysis, data center comparison, and like Megan said, if you have any questions, go ahead and throw them in the chat. And I don't have anybody with me today, so I'll try and answer them as best I can when we get to the end. All right. So with that, basically we're trying to lay the foundation here within your environment. What you see here is one of the 4 main pillars, optimizing capacity. And as we go through this, it's going to be important to realize that these metrics can change based upon the context that you're viewing them in. So the same metric name is going to potentially exist for multiple objects within your hierarchy. So it's important to take that into account and remember that the object that you're looking at, just so you can have a better context for reporting purposes. So this is kind of the classic stack that we're going to be going through here. And we're going to start off with the total capacity metric. So total capacity is going to be, as it says here, all of the available capacity for an object. So it's going to include your overhead, your HA, your buffer, and all the usable capacity in your workload. And we're going to define all these terms as we go through. So for this slide, just understand that total capacity represents everything in your environment. And then we're going to start building upon those so you can see how each of these impact your usable capacity. Okay, so first of all, overhead is referring to the resources that your hypervisor needs to manage your virtual machine workloads. And this is automatically included in the capacity planning calculations right out of the box in vROps. Next one down, high availability. Leveraging your cluster configuration and the ESXi hosts within to provide the failover protection. High availability calls back to admission control to ensure that there's sufficient resources that are reserved. Those reservations are respected and available for if or when a host failure occurs. So that's what the high availability number is. Next up, this came new in vROps 8.0. We introduced the capacity buffer, and this lets you add a user-defined buffer for your capacity and cost calculations. This is for customers that want to reserve capacity for planning above and beyond what's already reserved by the high availability metric. So just giving you, a little bit more flexibility there. This is going to add a new metric into your vROps console called usable capacity after HA and buffer. And let me go, well, you can see it there. Basically, this is showing kind of how it appears on this graph here, how it's represented there as the percentage. Okay, so next up, usable capacity after HA and buffer basically is the remainder of the resources that can be consumed by your workloads. So we're pulling out high availability, overhead, and buffer, and this is the total capacity number that we end up with. This isn't the necessary, it's not the full resources that are given to a workload. It's just what you have available to grant to them. Okay, and finally, this is a fairly easy one. Your usage or utilization is the amount of resources currently being used, that the workload is receiving from your hypervisor. And then we can add to this demand. So demand is the amount of resources that a particular workload is asking for. So if your usage is low, you're not going to be demanding more than is available. In this example above, we still have usable capacity because the demand hasn't yet reached that usable capacity level. But if the demand from a workload goes over the usable capacity, then we're going to end up with a contention situation. So this is where you run into where your demand is higher than your usage or utilization. That's going to bring on your contention. And this can be caused by things such as CPU ready time, swapping, hyper-threading settings, so on. So in this case, the VM is asking to use more resources, but it can't. They're not available to it because it's not getting what it's asking for. So that's where we have our contention problem. Okay, so let's shift gears a little bit here and go into the console. So here we're looking at a metric correlation example. And in here you can see a graph of the CPU demand. And that's basically, it's been over 100% for a pretty long time here. And, the CPU is basically just showing that it's experiencing contention for those CPU resources. So if we pull up the alerts here, we can drill down into the symptoms. And in this case, vROps is indicating that the 100% CPU usage for an extended period of time is generating this alert. Now, this alert can then be used in a few different ways. It can just be used as an informational thing to alert you to the problem. It can be automated to give you, something actionable, either through vROps, or you could trigger a ticket like through ServiceNow, to go open an incident with your service desk. So there's a few different ways that we can handle, when we're going over capacity, ways that you can handle that through vROps. So when we look at buffer versus headroom here, the main difference is that headroom is a workload optimization setting, and it's not going to be affecting capacity directly. The cluster headroom is indicating that the percentage of resources that should be free to act as a buffer to deal with resource spikes is available. There's migration recommendations that you can see here that they're basically going to show you how you can help rebalance your cluster when it exceeds those cluster headroom thresholds that you've set. This headroom is basically put in place to control the maximum desired utilization of your clusters in the data center. And this is a fully configurable setting within vROps. Okay, so if we go to the next screen here, we've got our workload optimization policy. And this is something that you can leverage to help fill a cluster before it starts moving workloads around as a rebalancing action. So within vROps, you have the ability to have it optimize your workloads for you. And this basically states how much you want to fill up that cluster before you start moving those workloads around. All right. So we're talking a lot about capacity here, and this is just kind of a good graphic to show you what the inputs and outputs are to the vROps capacity engine. For the inputs, you've got your usable capacity, which again is normally equal to the total capacity minus high availability. But again, depending on the context that you're looking at it, in some cases, your usable capacity will be equal to the total capacity for objects like VMs, data stores, data store clusters that don't necessarily have a high availability metric directly associated to them. The capacity engine analyzes your historical utilization and projects the future workload by using the built-in vROps predictive capacity analytics. And this is based on basically industry standard statistical analysis models of the demand behavior of VMs. The engine is going to take your demand and usable capacity metrics as live inputs, excuse me, from your environment, and it's going to generate output metrics, time, capacity remaining, as well as recommended size and total capacity. The projection window for the capacity engine is looking 1 year into the future. And the capacity engine is consuming data points every 5 minutes from your environment to ensure that you're getting a real-time calculation of those metrics. Okay. Excuse me. So when setting up capacity planning, there's a few settings in the policy to determine how conservative or aggressive you want to be with your capacity planning numbers. And some of this should be attributed to things like your purchasing cycles, SLAs, performance requirements, things like that. Basically, if you're running a conservative plan, then the time remaining calculations are going to be looking at the upper bound projection. So meaning that you're going to be alerted to potential capacity deficiencies further out, giving you more time to react. On the opposite end of the spectrum, the aggressive approach looks at the mean number there for your time remaining calculations for usable capacity. And this is going to give you a bit less warning before your capacity runs out. So it just depends on how critical your environment is, I would say. And this is another view that shows a little bit better the way the graph plays out for the conservative and aggressive calculations. You see the orange line above, which is the upper bound of the projection. This is what the conservative number is going to use. And then the dashed line at the bottom is going to be what the aggressive prediction uses. Okay, so with that, let me shift over to a demonstration real quick. Okay, so can everybody see this? Megan, can you see this okay?
Yep, we can see it.
Okay, fantastic. So we're going to do kind of a quick step through in vROPS. We're going to start with the production reclamation. So I'm going to click on reclaim within vROPS here. It'll let me move things around. There we go. Okay, and we'll click on our production south cluster. And we'll come in here so we can see down below, we've got 0 days remaining until our disk space runs out. So disk space is our most constrained resource here. CPU and memory, we're not going to worry about now because we're already out of disk space. So this is what we're going to focus on here. And if I scroll further down, it's going to give me a few different recommendations. Option number 1 is going to be reclaiming resources that aren't currently being used, or option number 2 is going to be adding more disk space to my environment here. So I'm going to go ahead and click on reclaim resources, and it's going to take us to the production south data center here, where I can kind of expand this and I can see all of the, in this case, we're looking at powered off VMs within the environment. So I can also look at idle VMs and snapshots that aren't being used. You can see the filter over on the right-hand side, where I can filter it for older than X number of days. So in this case, I'm just going to look at powered off VMs, and I can take, let's say, the first 2 VMs here and select those, and I can exclude these from this reclaim procedure. So I'm going to just exclude them and basically take them out of the mix, not have them be considered as part of this reclamation. So we'll click exclude, and now I've got the rest of my VMs in here, and I can select all of the rest of them. And I can click on delete VM. So these are VMs that are no longer needed for whatever reason. Obviously, you probably want to check with people before doing this. When you click on delete VMs, it's going to show you the number of VMs you're deleting, your cost savings, and the disk space that you're able to reclaim here. So I've gone ahead and deleted those VMs. And we'll go ahead and refresh this, and we can see that there's no VMs left to reclaim in the powered off section here. And my data center in production has gone back to the green setting, so there's no more alerts there. Okay, so the next section we're going to do is a what if scenario, so the production what if. So I'll click on that. And let's go ahead and scroll down here. And here we see that memory is projected to run out in 65 days. But the production cluster is showing more than 1 year worth of capacity remaining. So what I can do here, if I come over here, let's see, we can look at the optimization recommendations here, and you can see down below that the workloads are pretty imbalanced between production central and production west. So I can come in here and click on optimize now and take a look at kind of a before and after, what vROPS has the ability to achieve here by balancing the workloads across the clusters a little bit better than what we see here. So we see basically the production west, the CPU workload is pretty high, 83%. And if we were to move things around a little bit, you see that in the after side, it drops considerably for the production west, and the production central is going to take on some of that load. So if I go next here, we can see all of the resources that are going to be moved around here, all the different VMs. And then we can see the reason why they're going to be moved. And you could exclude some of these if you wanted to. If you were using vSphere tags, you could have a tagging placement where it would basically prevent the VMs from moving based on operational intent, let's say, or licensing reasons, things of that nature. So you can definitely prevent things like that from mucking up your environment. So if we were to begin action here, it would go through and perform the rebalance. And if I click on refresh up here, it's going to show, obviously this is just a demo, so things are happening a little bit faster, but basically it would rebalance and show on refresh that everything is fully optimized here. So that's the what if scenario. And then the last one is the CPU, the CPU utilization. So we can come down here and we can see down here at the bottom that there's no resources that are available to reclaim here. So the only option that it's giving us down at the bottom, excuse me, is to add more capacity. So we need 16.14 gigahertz, to add to this particular data center in order to be above the critical threshold that vROps is giving us. So that is basically showing us the three different ways that we can look at resources and do capacity planning, either by reclaiming resources or planning out into the future for those resources. Okay, so let me shift back over to slides. And so far we've been talking about taking live numbers from vROps and leveraging them to look at your environmental capacity and time remaining. But vROps also has a sandbox to kind of play in and see what adding or removing resources from within your environment would do to your capacity planning figures. And this is under the what if analysis section within the main structure of vROps. This tool is going to let you look at different scenarios within your environment, both from a traditional and a hyper-converged perspective. So you can see what changing your environment around, adding more hosts, if you needed to bring on more VMs, what that would do to your overall capacity numbers, and based on your current growth, how long you could expect to have that capacity within your environment remain and when you'd run out. And then the last thing with the what if scenarios, you can do data center comparisons for comparing your private cloud data centers. You can also compare this with different public cloud providers as well. And basically this is leveraging your capacity planning numbers along with cost drivers that you can input into vROps yourself and basically show individual server cost. And the main output here is basically giving you the ability to see how much a workload is going to cost to run on your different data centers, making sure that it'll fit within those data centers. And then the same thing with public cloud providers. If you wanted to see what it would cost to run something on a particular cluster versus moving it into an AWS GovCloud or Azure, something like that, you could kind of get a cost comparison there before actually moving things around. So that brings us to the end, kind of a quick little snippet on capacity planning. Are there any questions that you guys have? Megan, was there anything in the chat?
There is a question here. It says it's two questions in one. They kind of go together. So does your vReps treat all servers the same in terms of capacity? And then the second part of that is, if I want to run my internal testing on slower hardware, can vReps distinguish between that and my live environment?
Okay, so within vRops, you have the ability of making custom groups and doing custom policies. So you could have a custom group and a specific policy that would be targeted towards those machines in your testing environment, or dev QA is a kind of classic example, where you would be able to kind of turn the heat up a little bit and make your servers run a bit hotter without generating a bunch of alerts. Obviously your consolidation ratios would be different. So you might be running an 8:1 vCPU to pCPU ratio, physical to virtual, things like that nature. And then you could have another policy for your production environment that, maybe it's mission critical and you're running 1:1 or 2:1 on CPU, memory over provisioning if you didn't want to do that. You definitely have the ability there to change the lens on your environment and view it exactly how you want to see it and how you want to measure it. So yeah, good question. Anything else?
Those are all the questions we have today.
Okay.
Great. Thank you so much, Adam. Thank you, everybody, for joining us today. As you can see here on the screen, please reach out to any of us if you have any questions. These sessions are recorded, so if you would like to view it later, send it to someone you know, please visit our Sterling website at sterling.com, and we have a proven performance page where you can find all of our past performance demos, as well as this one will be uploaded as well. Everybody just have a great rest of your day. Thank you.
Thanks, guys.